just go from there as to questions that we have. So 2017, number 10. If you need it, look at your Scantron real fast, see if you missed it. This is the Saturday, number 10. 2017, number 10. Let me get my freezy button too, that way we can kind of go back and forth. You guys don't need me to read all these, right? Okay. We have the differential equation. Ooh, it has a minus. Pause. Eyes up. Is that possible to solve by hand? No. So no matter what you think you read, you will never be solving for y equals f of x if there's a plus or a minus that cannot have the y being factored out. Okay, go back to what you're doing. What is the approximation for f of 3 starting from f of 2 with 2 steps of equal length? So, Alan, what x's am I going to go to? F of, does that make sense? And then f of, but careful, these are going to be approximates, right? Okay, so this is technically, if you want to think about it, kind of like my y sub naught. This could be my y1, this could be my y2, if we're thinking of Euler's. With Euler's, you start with the previous y value. Remember, Euler's is, in essence, b plus mx. It's a lot like a tangent line, except it goes backwards in the sense of it's b plus mx, not mx plus b. So I start with a y value from before. My slope I get from my differential equation plugging in the point before, so x minus y. And my x will really be more like a delta x. It's going to be my h, or my step size, and I'm going by halves. Does that make sense? So then I would go ahead and, ooh, no calculator, go team. So 2 minus 6 is going to, 2 minus 8 is negative 6. Negative 6 cut in half is negative 3. 5 and negative 8 and negative 3 is 5. You guys agree? So then we would go ahead and go one more. 5 plus, plug in the x and y of the previous point. So 2.5 with its approximate y value of 5 times the 0.5. I don't know about you guys, but I hate decimals when I'm doing by hand work. So I would go ahead and make this a fraction. That'd be 5 halves minus 5, which would be 10 halves times 1 half. I end up with negative 5 halves times a half, negative 5 fourths. Did I make a mistake, John? No. Okay. Give me 1 sec. So negative 5 halves, negative 5 fourths, 20 minus 5 fourths would be 15. Do what you need. Double check that I'm right to get it what you need it to be. John?
I just realized the practice when we're doing this week is the one we took on Monday.
In the email, there are 2 exams. So, does that make sense? Yeah. There you go. So then your practice one will be this one, the 2017. And then for them, their practice one, what I put on the board yesterday was for the majority of you. Corey, what was your question? Okay, 2007, number 5? 10. Okay, I'm keeping it up there for a couple more seconds. Oh, wait, this was? This is 2017.
Yeah.
Oh, you went 2013?
13.
Got it. You can just say Monday or Saturday if that helps. Okay, so then, John, this is your guys's. My Monday people, this is number 10 on your mock AP. Not your practice, but your mock. Okay. Zoop. It sure looks like they want me to actually integrate because they give me the answer to the integral I have to solve for k. Hey, kiddos, why is this not arctangent for those of you who are seeing it? I have a u squared, I have an a squared, but I have an x. So this is good old-fashioned AB. Well, I guess arctangent was AB also, but good old-fashioned u sub. I know some of you have gotten into a habit of doing a lot of mental math, being like, psh, I can do this faster because I'm in BC. Don't make mistakes. As you go from 0 to k, I'm going to cross out the 0, cross out the k, because technically they're x bounds, and I'm going to use. I'm going to end up with 1 over u times an x that's going to cancel out with the other x. So I end up with 1/2 the integral, crossing out the 0, crossing out the k, so they can't take points away. 1 over u du, which will end up equaling, I know it's not an FRQ, I'm just solving as though it were. I'd have 1/2 ln of, let's get back in our x squared plus 4. Now I can bring back in our 0 to k. Most of you don't do this, but AB do. Eyes up here real fast. Eyes up here real fast. When you take the integral, would you ever rewrite it? No. You take the integral's gone, right? We're all on the same page. Okay, you would not imagine how many points I had to take off. Okay. No, I think it was AB. I think it was AB, but my head, maybe some of them are BC. Okay. Then we go ahead and plug and chug, and when we plug and chug, you end up with a 1/2 that's out. You got it, Corey? ln of k squared plus 4 minus ln of 4. And then solve. Was anybody needing me to keep going on this? We're okay? Okay. Gabby, go ahead.
11 on this one.
On this one? Okay, we're on number 11, the 2013, the Monday exam. Ooh, it's a Taylor polynomial, just in case someone else wants to pay attention to a Taylor polynomial. Okay, the third degree makes sense. It goes up to the third power of x, right? What is the value of? Oh, I love this one. Some of you guys, it's one of your weakest points, so it's up to you as to whether you want to focus if you've tried it, and if you haven't tried it, don't focus. You'll practice it soon. F triple prime of 4. What was the mistake that you found that would have given you a 5?
I have 3 mistakes. I circled all the right answers and I bubbled in the wrong ones.
On the actual AP, what are you going to do?
I'm not taking it.
On
Drop it in the class.
the actual AP, what are you going to do? What are you going to do?
Check.
Okay. Kiddos. It's okay. It's okay. You got this. You got this. Come back. The point is find the ones that you made mistakes on. Pause. Gabby, this was your question. Okay. Shh. Focus on it. Either on what you're doing or on what we're doing. I have written f triple prime of 4 all over 3 factorial. Why? What am I trying to show you? The coefficient and where it came from for the third degree term. So we're going to set the 1 over 512 equal to the formula that would have gotten it. So this isn't the third derivative. This is the third derivative over 3 factorial. So I take my 1 over 512. That would have come from this. I can solve for the third derivative by multiplying by 3 factorial. So I have 6 over 512. I reduce by dividing by 6, and I end up with 8. And, ooh, 6 isn't going to 32. Never mind. 2. Nope. Yeah. Over.
No, 3. You divide
Oh, 3 goes in?
You divide it. No, you divide it by 2. So it's 3 over.
Oh, thank you. Over 256. Got it. Pause. Yeah, we're good. Okay. I'm ready. Keep it going, Corey.
14 on this one.
On this one. 14 on the Monday.
Yes.
Okay. Ooh, nice. It's a limit problem. Nice, it's a limit problem. If a and b are positive constants, then limit as x goes to infinity of. Question. Technically, since they're both ln's, couldn't we do a little infinity over infinity L'Hopital's action? What do we do with L'Hopital's? Take the derivative. We're allowed to because they're both infinity. Why is it nice to take the derivative? Because check it. I have 1 over times b, bx plus 1. And then I have 1 over times 2ax, ax squared plus 3. At which point I would simplify. Don't hurt yourself. We love you too much. Then you have b times ax squared plus 3 all over 2ax times bx plus 1. limit as x goes to infinity. How can they ask us to do it? Because look, they're tied. And we end up with AB over 2AB, which is 1. Whoo! L'Hôpital's degrees. We're tied. 1 over u times u prime. Caroline. 14? Okay. 13, I'm going up. Okay, so on number 13. On number 13. Number 13. The graph of f prime. I love it. We have an initial clue. I love it. Ahem. Katrina, it's for you. Ready? Integration as net change. How do you find the value at a final given the value at an initial and a rate? Integration is net change.
You have to estimate though.
How?
You gotta make small rectangles.
Could be. It doesn't say it is. Could be. So could be. It's kind of up to you. You could technically. Couldn't you do a little under approximation? And then couldn't you technically do an over approximation? And then couldn't you see if that's enough to figure it out? The under approximation would end up being a base of 5 and a height of 2, so that'd be 10. The over approximation would be a base of 5 and a height of 4, that'd be 20. And I know I'm adding f of 0, which is 20, plus some sort of approximation of the area. So it's going to be higher than 30 and lower than 40. Higher than 30 and lower than 40. Pause. Did you understand integration as net change? Okay. They gave us the graph of the derivative. Okay. They wanted me to go back to the original. And they told me where to start. Integration as net change just says, hey, and maybe you could put it in words. I'll give you a final where it is at a point. If you can just give me an initial and think about either area or integrals. Sometimes you'll be solving the integral, sometimes you'll be thinking area. Does that kind of make sense? And you could have done like little rectangles and triangles. Like you could have made it more precise. I just was lazy and thought, well, let's see what the lower rectangle looks like in the upper rectangle. And then I figured out there was only one that was in between. Another one, 2017 or 13? 16. Katrina, what's next? 17?
Saturday one?
Yeah. Okay. We're going to 2017 after this for a little bit, but Corey, you're still in 2013, right, Corey? Okay. Monday one, number 16. Oh, I love it. Look at this guy. Is he logistic? Is he a thumb trick? Ah, thumb trick. Antiderivative. Antiderivative means integral, right? So this wasn't meant to be lice minus licht, even though you might have thought it was. This was meant to be, wait, can I pull out a p and can't I say 100 minus p?
Yep.
How do I integrate when I have two separate fractions that I might want to split into? How do I do that?
So you take the 100 p.
What do I plug in?
0.
1 over 100 minus 0 is 1 over 100. Now I cover?
100.
Plug in 100. 1 over, oh, look, they both have 1 over 100. So I can pull over 1 over 100 and I can do, careful, as it makes, I'm going to do ln of p minus ln of 100 minus p. Where'd the minus come from? U sub. U is 100 minus p. Du is a negative. I need the negative when I go to take that integral. And it says, which of the following is an antiderivative? Where's the plus c? They're like, no, no, no. Which of these fit the pattern after a c has been established? So yes, there's a plus c. But they said which of these is not the only, not the general, just an antiderivative. Well, I need 1 over 100 for everybody. Doesn't even have an ln. Forget him. Subtraction would be division. I could make this ln of p over 100 minus p, but none of those look like that. So I can't do that. 100 times, can't do that. Plus, no, u sub. Dun, 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 dun. No, it's 5? Then that's what you should get on the actual AP. Actually, even higher because we've worked more. Okay, hold on. Katrina, help me. 2017, number 15? Okay, guys, we're on the Saturday final, number 15. Oh, yeah. AB had this one, too. They didn't like it either. I am going to be as honest with you as I was with them, okay? As to how I would have solved this. 2017, the Saturday final, number 15. Okay, can we all agree? 2 guys, 2 separate sides of a graph, both going to meet each other at a diner. They go up to the door, it's locked. There's a hole, they can't get in. But did they meet? Yes. For all intensive purposes, yes. They met. The limit does exist. That is true, not false. So therefore, not A. Letter B. The limit as x approaches 2 of g of x does not exist. 2 guys, 2 cars meeting at 2 separate locations. The diner burned down and is somewhere else. I don't care. They're not meeting. Does not exist. Also true. Now, listen to me and don't react. This is how I did it with AB. I had them all convinced and they got really mad at me. But this is literally how I would have thought about it. For letter C, the limit as x approaches 1. Okay, plug in f of 1 times g of 2. But wait, hold on. It's a limit. I know plugging in is a shortcut, but it's a limit. So when I go to plug in 1, okay, the limit does exist. So I could go ahead and say that the limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x plus 1. This guy is 0 times, okay, let's go over here. Plugging in 1, 1 plus 1 is 2, g of 2. Wait, but the limit does not exist, so therefore this is literally what I would have done. And I would have gotten DNE, listen, and I would have said, oh, does not exist, true. I would have marked him out, pause. I would have kept going. And I would have said, this guy, okay. The limit as x approaches 1 of f of 2, there's no problem at f of 2. And as x approaches 1, there's no problem in g either. So this one definitely is also true. So then I would have said, well, that's definitely false. Sorry, in the sense of not false. This one's definitely not an answer. That one's definitely not an answer. That one's definitely not an answer. Huh, I wonder why that was the answer. That's literally what I would have done. Okay, now I know it's not super precise. So let's talk about it. As we come over here. Some of you might have a better explanation than me because literally I was pretty convinced that D was the right answer until I went in and saw that it was not the right answer. Not in the answer key, but I actually tried it, and I was like, that's fine. Okay. Without going into the epsilon delta definition of a limit. As x approaches 1 of f of x, okay? As x approaches 1, okay? The limit of the x values will be, right, going towards 1. The function value will be 0. When you plug in f of 1, the algebraic method would say f of 1 times g of 2, right? That's what the algebraic method would see. As x approaches 1, the two-sided limits do agree as I come from 1 from below and 1 from above. F of 1 of both of those from below and above the limits would still be 0. As I come in for g of 2, as I come from below 1 and above 1, I know that it has me going towards g of 2 from either direction. I don't like my explanation. It makes sense in my head. I think technically since the x value is not the discontinuity, we would go ahead and plug in g of 2. The hard part is my rationale as far as explaining why that's true is not coming off the top of my head. And so in period 1, I was like, I'll get back to you guys, sorry. But obviously it's C because it's not A or B or D. The problem is, the dilemma is, I'm trying to figure out whether this would be 0 or whether this one would be 2. Give me a day to think about it for A, B, and then I'll get back to you guys too. And if any of you guys have a rationale as to why, I would love to hear it. I'm going to probably break it up into piecewise functions and look at it like that. It'll be easier on my brain. But I don't want to take class time on it right now without knowing exactly the direction I'm going and how long it would take me to get there. So give me a second. As far as give me till tomorrow, remind me about number 15. But do you guys see how my process of elimination still got me to C? Still got me there. We just need to work a little bit deeper maybe on our understanding of limits, myself included, to see why it is what it is. So Jason, feel free to chime in after school today if you want to talk about why it is what it is. Can we keep going 2017, 2013? Alan?
The Saturday one, number 19.
Saturday 1, number 19. 2017, number 19 if you want it. You might want to peek at your Scantron if you took it on Saturday to see if you missed it. Oh, nice. Hey guys, attach it to a forever card. Approximate, nah, that doesn't do it. Attach it to a forever card. When you see tangent line, you should think y minus f of a equals f prime of a. X minus a. If we plug in, careful with the parentheses. The derivative. Now the name of the game is unit circle. Unit circle, pi over 2, 0, 1, which means cosine is 0, sine is 1, which leaves me with y minus 1, 0 plus 1, equals negative 2. How do you use a tangent line to approximate a y value? Take the x equals 1.5 and plug it in the only spot that an x is supposed to go. And we end up with y will be approximately, or I could say f of 1.5 will be approximately the y value, which will be 1 minus 2 times, I hate 1.5. Fractions make so much more sense. 3 halves minus pi over 2. That 2 comes in and ultimately ends up canceling all those guys out. And you end up with 1 minus 3 minus a negative pi. I'm ready. John.
18 on the Monday.
Okay. 2013, number 18. 2013, number 18. Is it an accumulator? Ooh. Okay. We have, it's not even an accumulator. We have the function of f. Let g, okay, we have g. Then let h, f of g. What is the value of h prime of 1? Okay, I'm going to not even look at that graph and the nasty clues. I'm going to say, forget it, I know calculus. H prime of x is going to equal f prime of g of x times g prime of x. So I'm saving time. Let's do a 1, and a 1. G prime, I see I'm going to need that. So g prime of x is going to equal 2. So as I come over here, I'm going to have f prime of, g of 1 is going to equal 3. So I need f prime of 3 times g prime of 1, would be 2, right? Because it's a constant. So I can plug in my 3, I can plug in my 2. My f prime of 3 is going to be the slope of the line with these 2 points. So my f prime of 3 is going to equal y1 all over x2 minus x1, which would equal negative 2 times 2. I would say A. Corey. Okay. Sticking to the Monday, going right to the end, number 27 if you want it. If I have lost you at any point, this is all recorded. It will be online. Ooh, an improper integral. I like it. Wasn't this equal to the limit as b goes to infinity of 1 to b of f of t dt, which equal the limit as b goes to infinity of who they told me that is, except instead of a b, they put an x. I'm going to put b's everywhere. So I'm going to have 20b all over the square root of 4b squared plus 21 all minus 4. As I check out this, I see the minus 4 is just a constant. He's going to chill. I see the degrees being tied in that square root of a quadratic will be a linear. So I can take 20 over the square root of 4 going to positive infinity. There's no sign change. A positive over a positive is a positive. If it was negative infinity, it'd be negative. Careful. Positive infinity, though, I can go ahead and take 20 over the square root of 4. 10 minus 4 is, I would say, A. Go ahead, Alan. Okay, number 2017, the Saturday mock AP, number 20. I see parametric motion. I see my position functions. The line tangent to the particle's path has a slope of, isn't that dy dx? Dy dx is going to be y prime all over x prime. Where t equals 3. So 2 times k times 3 all over 1 over 3 plus 1 equals 8. So I have 6k multiplying by the reciprocal of 4 equals 8. 6k equals 2. I would say 1/3. Katrina.
On this one,
Yeah.
number 27.
Okay. Mock AP, Saturday, 2017. I like it. I like it a lot. Logistic. It's all about fitting it into a certain pattern. Kiddos, could I see this as y prime equals kyl minus y? Good. So then it says where t is the time, it gives me an initial, p of 0 equals 25. What is the greatest rate of change? What is the steepest the slope gets? In students per second of the number of students in the cafeteria. Pause. When does this happen? This happens exactly at L over 2, but that would be how many. They're not asking for how many, they're asking for what is the rate. So it's going to happen at or when y equals 100, but what do I have to do? I have to come back here and plug in 100, but problem, who else am I missing? Oh, no, just right back here. Sorry, I have it. Sorry, y equals, it would be p equals. Are we okay with that? Yeah. Okay, so we plug in 100 to the rate. So we'd have 1 over 2,000 times 100, 200 minus 100 would be 100. I can take off those zeros. I can take off that 0. Is that at 5? Or is it the rate 5? Yeah, 10 over 2. So it's all about what they asked for. They asked for the rate, not the number. And guys, pause. They love it if they give you one where you get to do the maximum rate. They love asking you for something weird. Don't just divide by 2. Make sure what they're asking is the population and not the time or not the rate. Give me another one.
28 from 2017.
2017?
Oh, no, 2013, sorry.
2013, number 28, the Monday one. The second derivative of an implicitly defined function. Remember, the first derivative, we need y prime over x prime. For the second derivative, there is a formula for this, right? I'm going to have to take the derivative I'm going to have to take the derivative of the first derivative, bring down the -2, it cancels, -3, good. But I also have to divide it by, guys, second derivative, parametrically or polar? You need x prime, right? There you go, kid. So you end up with -1 over 2t to the 4th. 45 seconds, I can try. Of which one, Saturday or Monday? Monday? And what number, Dylan? Dylan, what number? 15? Okay, 15 on the Monday one. Ah, interval of convergence. We have to do a ratio test. I don't know if I can do it. X plus 3 halves. I can just do absolute value, right? Those degrees are tied. That would just be 1. These ones are going to cancel out. I'll just end up with an x plus 3 halves less than 1. You can leave if you want to. Bye. Dylan, you'd have to test the endpoints by plugging in. Does that make sense? So then you would go and plug in -5 halves, which would be -5 halves plus 3 halves would be -1 to the n, which would make this -1 to n. That's going to be positive. P series, it's going to diverge. Make sense? But then this one, I think, is going to still be, it's a positive one, so it makes no difference. So then the alternating series converges. Is that okay?